This video is going to talk through what happens when you have a system of equations with no solution, and I want to show you graphically as well as algebraically what happens when you have a no solution system. So here I have a system where I have no solution, and that occurs when your lines are parallel, and lines that are parallel have the same slope. So it's easy to see the way that both of these lines are presented in slope-intercept form that they both have a slope of -2, but they have different y-intercepts. So I'll graph color-coded. Graphing this, I'm going to start at +1 on the y-axis. My slope is -2, so that means that the line is going to fall as I move from left to right. So I'll move up 1, down 2 in the negative motion, or negative vertical and then positive horizontal. So that's the first line, graphing some points. And then my second line, I'll do it in a different color. So I'll start this line at -3 on the y-axis. And my slope once again would be up 2, that's positive, and then in the negative direction 1. And you can see that the lines are parallel to each other. They will never intersect. They have no points in common. But I would like to show you what happens when you try to solve this system algebraically. And we'll just go ahead and use the substitution method on this system. Since both equations are already in a position where the y's been isolated, coefficient on y is +1, y has already been isolated, so I can simply just set the two equations equal to each other in this case. Since I started with y equaling y, both of them have y already isolated, so if I set y equal to itself and then make the substitutions with the equations, I'm going to attempt to solve this. So when I add 2x to both sides, you can see that the variable is going to sum out of the problem. I would have 0 plus 1 on this side, and then 0 minus 3 on the other side, and then what remains is 1 equaling -3, which is a false statement. So my conclusion would be this system has no solution. So when the variable sums out of the problem and the two numbers that remain are not equal to each other, then you should conclude that this system has no solution, no common xy point for both equations that will make both of them true at the same time. And then if you graph the lines, you can see that they're in fact parallel to each other, sharing no intersection point. So let's look at what happens when you have the infinite solution case. So here I'm going to go ahead and solve this by substitution first. So here are my two equations, and I can see that in my first equation, y has been isolated with the coefficient of +1. So I'm going to move to my second equation. And where the y occurs in equation number 2, I'm going to substitute in -x plus 4, which is why the method is called substitution. So this is what I'm now going to solve. By +2x, -2x, +8 equaling 8. And it's easy to see that when I add these two together, they're additive inverses. They're going to sum to 0. So I have 0 plus 8 equaling 8. 8 equaling 8 is a true statement. That's a true result. So once again, the variable has summed out of the problem, but the two numbers that remain are actually equal to each other. So this is a case where I would state that I have infinite solutions. Or you could say my solution set is all real numbers, all real numbers. And if I were to graph this pair of lines, it would actually end up graphing as a single line because they're actually the same line. So I'm going to go ahead and graph, since that's in slope-intercept form. I would start graphing at +4 on the y-axis. My slope is -1. That means that the line is going to fall as I move from left to right. The second line is presented in standard form. So if I take this and convert it, I'll copy it down here. If I take this and convert this to slope-intercept form, I'm going to subtract 2x from both sides. And then I divide all three terms by 2 to isolate y, and I end up with -x plus 4, which is exactly what I started with the other equation. So you can see that both equations are the same. Let me zoom the camera out so we can see the full picture. You can now see that both equations result in the same y equals mx plus b format, which means that they originally represented the same line. They're actually the same equation. And when I solve it, the variable leaves and the numbers that remain are actually equal to each other. So this is my case where I have infinite solutions or all reals. So when this happens, you would need to state infinite solution or all real numbers. Just like the problems above, you would have to state that this particular system has no solution.